Hi, my name is ICRA2023 and I will present you our 2023 ICRA paper entitled Continuous Time Gaussian Process Motion Compensation for Event Vision Pattern Tracking with Distance Fields. Let me first give you a quick introduction to event-based vision. Unlike standard cameras, event cameras do not take snapshots of the environment. They provide an asynchronous stream of events that correspond to intensity changes in each pixel independently. While the problem of feature extraction and tracking is quite mature for standard cameras, it is still an active field of research for event-based vision. Novel algorithms and paradigms are required to address this type of unconventional data. Overall, our work addresses the issue of pattern tracking for event data. Given a simple set of x-y coordinates as a patch seed, the proposed method collects events in the neighborhood of that seed to populate a small batch of events. In order to perform tracking, we first correct the patch motion locally in the image plane using a continuous SE2 motion model based on Gaussian process regression. Then, given two consecutive batches of motion-corrected events, we estimate the discrete homography transformation between the two batches using Gaussian processed distance fields. We also propose to perform the homography registration in a batch-to-template fashion to allow for long-term tracking. The SE2 motion compensation is built upon a continuous model of the patch trajectory in the image plane. We model the XY translation as well as the orientation theta with independent Gaussian processes and their corresponding inducing values. These inducing values can be seen as control points of the trajectory. The key of our approach is to model the occurrence of events with another Gaussian process, leveraging a spatiotemporal kernel. On the right, you can see an example of inference performed with the proposed model, considering that no motion happened during the data collection. Given the events in a small batch, it is possible to estimate the control points of the patch trajectory by maximizing the marginal likelihood of the event data. By considering the trajectory control points as hyperparameter of the kernel, this step corresponds to standard hyperparameter learning for Gaussian process regression. As illustrated on the right, the proposed method provides sharp motion-compensated patches. However, the assumption of SE2 motion is not realistic enough for long-term pattern tracking. Our paper introduces an homography-based patch-to-patch registration algorithm. Considering a patch of motion-corrected events, it is possible to infer a distance field that corresponds to the distance to the closest event in the image plane. Such distance field is obtained by applying a simple logarithm to the occupancy field mentioned previously. Considering another motion-corrected patch, the distance field is used in the cost function of a nonlinear least square optimization to estimate the 3x3 homography matrix between the two consecutive patches. To allow for long-term tracking, we introduce the use of a template that is built and refined on the fly. The template is obtained by thresholding the histogram of accumulated events and by performing a skeletonization of the resulting patch. The track associated to a patch corresponds to the transformation of the original seed with a combination of the local SE2 transformations and the discrete homography estimated. Throughout real-world experiments on public datasets, we show that our method competes with state-of-the-art methods in terms of accuracy. The availability of both SE2 and homography estimates allows our method to terminate tracks when the difference of trajectory estimates diverges over an arbitrary threshold. As a result, our method provides a high ratio of good tracks, making it easier to integrate them in downstream applications such as odometry or SLAM. We have made our implementation open source. You can find it following the QR code or the link below. I hope you enjoyed the content of this video. If yes, I'm looking forward to discussing with you on our poster session on Tuesday morning.